Right, in this class, we look at sketching graphs of modulus function, and the questions are here given, saying below. In each case, use a graph to state the range of the function. But for you to state that range of the function, you have to sketch the graph. So when it comes to sketching graphs of modulus functions, it first suffices to understand what the modulus is. So, of course, you have that redefinition of the modulus, but now in our case, we just take it. If I have a function, usually, like in this case, given, you have a linear function that is given, so ax plus a constant p. What you're saying, the modulus gives you always a value that is what? That is positive. To always give you what? A positive value inside. So we expect that everything we're gonna get here has to be in the what? In the positive region of what? Of our graph. That is, if I have an x or y plane, because of this modulus function here, just the way it is, it would mean I expect things to appear what? To appear in this upper region here, like this, because this is what? The positive region here. Okay, but there will be cases in which it will appear in the negative region, and we'll look at those rules as we continue to go. So I'll start with question 1. So question A here, a given f of x, and it says modulus of 2x plus 8, and they're telling you to find or sketch this graph. So first of all, think of it as the function f of x being equal to just 2x plus 8. How would you sketch that? So to sketch that, what you need is, so you're saying if this is equal to this, where we're saying our f of x is just y equal to 2x plus 8, you're saying for you to sketch this, there are very important points that you will need. That is, first of all, the x-intercept. The x-intercept is just a point at which the y, at which y is what? Is 0. So x-intercept, I'm going to make y equal to 0, so that I have 2x plus 8, and then this would mean 2x equal to negative 8 divided by 2, divided by 2, I get x equal to negative 4. So this here is my x-intercept, that is where the graph or this line is cutting my what? My x-axis. Then I have what I call the y-intercept. The y-intercept is when x is 0, so we make x equal to 0, and we just remain with what? With 8. So this is my y-intercept, that is my x-intercept. So if I have it in this case, say I sketch it, it's just going to take the form that way, and this is our y, and that's our x. So we just have where it is graph cutting the y, so it's cutting the y at what? At 8. Let's say that highest point there we have is 8, and it's cutting also at negative 4. Negative 4 is this side, so you see there, and it's going to be a slant line, a line like that. Okay, so it's gonna cut that way, and this is how it would look just if it was what? F of x. This is the line which is going to be y equal to what? Y equal to 2x plus 8. Now that we've put this in a modulus, what is going to change? What is going to change is everything that is in the negative region will give out positive values. So in exchange or in turn, you're going to have what? A reflection of those negative values on what? On the top. So it will be there like that. Because of that what? Modulus sign. You will not get any point that is what? That is negative. You will not get what? Any point that is negative. So what does that mean? So if we are to redefine or to rewrite this, our modulus, which is 2x plus 8, like this would be, so this would be 2x plus 8, like this, if what? So we solve this for 0, say 2x plus 8, you equate it to 0, and so for x. So when you equate it to 0 and you solve for x, you just have negative what? Negative 4. So this is when what? When x is greater than what? Greater than negative 4, like this, greater than or equal to negative 4. Then you have the negative of it, which is negative 2x plus. So the negative there is multiplying throughout. That's if our x is what? Less than negative 4. This is how you would define that modulus function. Now, what does that mean? So the same way we sketched this one, it's the exact same way. I'll sketch it here on the lower point here. So see where we are saying if it's what there's a common point there which we have, which is negative what? Negative 4. I'm sure you know where we're getting that negative 4. So which is that point. So the positive side, it will be x being greater than what? When it's greater than negative 4. So that is this side going this way because it's positive, and that will be 2x plus what? Plus 8. And the other side, the negative side, is going to be this side, like that. So this will be, you multiply that negative, just have negative 2x minus what? Minus 8. So that's what you get this side. So this is how you sketch this graph. And I'm sure you understand from this first part how we are obtaining or reaching to this what? This point, and how we will define that modulus there. So now we are going to check what are they telling us? They are telling us to also identify the what? The range of a function. So you see, of course, we are getting all positive values, is what you'll be getting, going up to infinity this way, if you can see, going up to infinity there. But then, what's the starting point? This is y equal to what? It's y, it's starting from y, which is what? Y is 0. Because when we're talking of the range, we're looking at what? The y values. So what y values in short are you going to be what? To be obtaining when you put here. So is here just going to give us all positive what? Y values, because this is from 0, from 0. So and 0 is what is included. 0 is part of that, because 0 is going to be what? 0 is part of this. So when I plug in here, so I'll get from 0 going what? Up to infinity, like that. These are not negative but positive. So up to positive infinity there. So these here are going to be what? My values that I want I'll be obtaining. That's my range. Okay, so now let's look at a different one from this. Okay, because of the nature of today, just look at sketching these graphs here, and we'll conclude from there. So another one that we can look at is C. This part B is just the same as we sketched, but C has a different case, because you see that f of x is equal to what? To 8 plus I have x plus 4, then there's a modulus, it closes there. So how is this one going to be? Of course, you can redefine this the same way we did, where you're saying the modulus of x plus 4, this is going to be x plus 4, then what? Equate this to 0, just have, you get x plus 4 equal to 0 gives you x equal to negative 4. So this will be this if x is what? Greater than or equal to negative 4, will be the negative of x plus 4 if x is less than negative what? Negative 4. Okay, like that. Now, this one has what we call a vertical shift. So a vertical shift means it's moving from its initial point where it was supposed to be starting. It changes point from there to a point that is what? Different in the y-axis. That is the vertical shift, because when talking of the vertical direction, you're talking of the y-axis. So I have that there. Okay, so you have that here, and you're saying what? So initially, if you are just to graph this here, to graph this modulus of x plus 4, that is going to be, so you have okay, so you have what when it's like that? So of course x here negative, so you have something like this, where this point is -4, and this point where it's cut there is 4. So you'd have something like this. But now what they're telling us is this thing has shifted, or it's moved 8 units up. So even us will move. So let's say 1, 2, 3, and we say this point here is 8. So say that's my 8, and I'll move there. So what does that mean? I'm adding in every shift. So in the y-intercept, it was 8 here. It was 4, I mean 4. Then we add that 8, and this here will give us what? Will give us a 12 when we add these two. So it means where the graph is going to cut next, this way, there it's going to be at what? At 12, because of that vertical shift of 8 units up, and there to go what? To go like that. So this is your y, and that's your what? That's x. So this is the graph of 8 plus modulus of x plus 4. That's how you sketch that. Okay, unless there's any question. Yes.
So the initial point, okay, so firstly, before we added the vertical shift, it was cutting, the graph was cutting at 4, and then it was moving from 4, which is the y-axis, and also -4 for the x-axis, right? So I am on the second graph. I'm not understanding why we're starting from -8.
I was starting from 8.
Yeah. Are we not supposed to start from 4 and then add 8 units?
Yes, we are at -4 here, right? So remember
I
here
mean for the y-axis.
For the y-axis. Oh, yes. You're not understanding where what?
The 8,4. 8,-4.
Okay, 8, -4,8. That is right.
Yes. Oh, yes, yes.
Here, this point, right?
Yes. What? Yes. So we're starting from there, but I don't understand.
Okay. So what we're saying is, so this point here, the 8 here, we're saying this 8 which is being added to here is what we're calling the vertical what? The vertical shift. So this 8 indicates that we have this graph from the starting point as what has shifted, that is shifted what 8 units above the starting point. So I said if we were to sketch the graph, just the graph f of x equal to this modulus of x plus 4. Here there's no vertical shift, so meaning its starting point is what is on that baseline or on that axis, which is the x-axis here. Because on this x-axis, what do we know about that? We know that y is equal to what? To 0. That's why the starting point is there. Then you go like that in your sketch. Now, the fact that you've had this vertical shift, it means what? Y has increased to 8. So meaning where you have to start is at a point. First of all, here you found your x to be -4. So you go -4, and y has increased from 0 to 8 because of that vertical shift, and you go at 8. So meaning that's where your graph is going to be starting, which is here -4,8, and we just do the same thing which we did when we were sketching there. And of course, because of this shift here, remember we were at it cuts what? It's x plus 4, right? So if I say y equal to x plus 4, what is going to be my y-intercept is when x is 0. So when x is 0, I get y is equal to 4. That's my intercept. That's where this graph is cutting the what? The y-axis. So at y equal to 4. But then there's a shift again. The shift is the same. It's shifted 8 units. So if it's shifted 8 units, meaning even to the intercept, it's going to move. The intercept will not remain at 4, but it will move also with that 8 units. So I add that 8 units and it will give me what? 12. So this is the 12 we indicated here, that this is where the new intercept will be because of this vertical shift. I don't know if that is clear now.
Yes, but no, maybe I'll understand when the next question.
Okay, let's do the next one then. Okay, so I want to do okay, let's just do D, the same D. We'll do D. Alright, so D. So D also has a shift, has a vertical shift, and it's positive, as you can see. So it's moving in the positive. The shift is in the positive y-axis. So when you're talking of the vertical shift, when you say a number here, vertical shift, you're talking of the y-axis. So like that, minus modulus of x plus 3. Our interest first is on the modulus. So I redefine that modulus like this. And this is going to be x plus 3. That is when, so if x is what? Is greater than or equal to negative 3. Then I have negative x plus 3 if x is less than negative 3. This is what I'm getting. Of course, I can sketch that again. So, sketching this here, what do I get? I have the negative 3 here. What is my y-intercept? My y-intercept is when this is 0, I get y equal to 3. When x is 0, I get y is equal to 3. So that's my y-intercept. So here, this point where we are, this point, that's negative what? Negative 3. Here where it's cut is 3. So this is how this graph is going to look, just this modulus of x plus 3. Then, but I have this vertical shift. So means what? I am moving 4 units is positive, so 4 units in the y-axis from my starting point. So what does that mean? I just draw this here. Negative 3 here. Then I've shifted 4 units. So this point is 0, y is equal to 0. Then 4 units would mean 1, 2, up to what? Up to 4. So let's say this is 4 here, and we'll have that point there. Then we'll go like that and go like that. So this is how it will look. But this here is going to be for the case when what? When you're saying 4 plus modulus of x plus 3. If you have f of x to be equal to this, because this here is going to be giving you what? Positive values because of the what? This positive value which is in front of it. So you get something like this. What will this point be? We forgot to mention this point. So if our intercept initially was 3, so we're just adding 4 because of the vertical shift, which is 4. So 3 plus 4, which will give us 7. So this point is 7. Okay. Now, let's go to our example. So this one here, which we've sketched, is 4 plus modulus of x plus 3. Then modulus. Now here there's a negative. So what will you be getting? So you know that in the modulus, when you plug in here, you plug in values here, you always get a positive value. But because of this negative sign in front, this negative sign here, it means when you multiply, well, every time you have a positive, it will multiply the negative, and it will make sure that it will make this here entire thing to be what? To be negative. So when you have a negative here, when you have a negative sign in front of the modulus, the graph will change from being like this to what? Facing downwards, to be inverted now because of that negative sign there. So you'll be having negative values, or values that will be less than that there. So what will that now mean? Our graph is going to look like, so our graph will be like this. Okay, so of course there's that vertical shift, 4 units. So let's say this is our 4, then it will be inverted, so like that, and like that. This is how it's going to look. Really, they are not most interested even in the axis, in the intercept, but where you're able to include them, you can include them. Where it is not viable or possible for you to include them, just leave it like that. But they're interested in in sketching, and of course here they're interested in the range in the question. So you sketch there, and you have y and you have x. So there was our 4, and of course we're interested in that 4. Our range, what would that mean for our range? Our range, we're going to be having now values that are less than what? Less than or equal to what? To 4, because that was our starting point, the vertical shift. So range is just going to be from 4 included, okay, not there. So I have to write the negative first. So negative infinity to 4 close there. So this here is going to be my range. So that's how I find this one. Okay. Unless there's any question here.
No, we're okay.
Okay. So which means we are good to do the last type, which is H, and I guess you will be able to solve every question when sketching these modulus. Alright, so H, which is f of x, so it's f of x. It has a negative vertical shift, and there's a negative there, and you have 4x plus 2. So how do I sketch that? I can take it again step by step by redefining this. So that means f of x plus 2 equal to 0. This will just give me what? Negative the other side, and it just becomes negative x is equal to negative half, like this. So means it will be 4x plus 2 if x is greater than or equal to negative half, and 4x plus 2 negative there if x is less than negative half. Okay, then from there, what do? I understand that is going to be, so the negative half here, negative half, so it will be that way, like that. And of course I can label that, the first way I labeled them, but now I have a shift and it's negative, so I'm going down, and there's this negative sign. What does that mean? It means we are going to what? Invert. So we have to first do a negative shift here from there to negative 6, then we invert it down like that. So this is going to look something like this. Let's say that is our negative half. Then we have our shift. So our shift is 6 units, negative 6 units, because this is negative 6 at front here, you can see negative 6, and just there's a negative sign in front here. It would mean I always get a negative value, and it would be like that and like that. So this is how this one is gonna look. So from here I can get the range. The range is going to go what? It's going negative infinity or negative infinity here, then all the way up to what the highest value of my 10 is negative 6, like that. So this here is going to be my sketch and my range. Okay, unless there are any questions, but this is how we sketch modulus functions.